Okay, in example 1, we're going to make a table of values to graph 3x squared plus 6x minus 4. I want to state the domain and the range. So first off, we're going to start with the axis of symmetry. Your axis of symmetry, remember, is x equals the opposite of b over 2a. On this particular problem, notice a is 3, b is 6, and c is negative 4. So I'm going to replace those. So I'm going to say x equals the opposite of, this case, 6 over 2 times 3, because a is 3. So you get negative 6 over 6, which is negative 1. So that is our axis of symmetry. That's the line that's going to cut our parabola in half. That's what we're going to use to make our table of values. When you make a table of values, this is going to be my vertex of my graph. So I'm going to put negative 1 right smack in the middle. And then what I'm going to do, I'm going to pick a couple numbers to the left. So I'll go like negative 2 and negative 3, and I'll go 0, and I'll go 1. Just so we can see what's going on here. Now, I'm going to find 3x squared plus 6x minus 4. So I'll start with negative 1. I'm going to change colors here so you can see what's going on. So I'm going to take 3 times negative 1 squared, replace negative 1 with parentheses, or the x with parentheses, plus 6 times negative 1, and then minus 4. Well, negative 1 squared is positive 1. 6 times negative 1 is negative 6 minus 4. And 3 times 1 is 3, so I have 3 minus 6 minus 4. So 3 minus 6 is negative 3, minus 4 is negative 7. So when I'm at negative 1, I'm at negative 7. That's what we call the vertex. Now, let's put in 0 for x. So I'll have 3 times 0 squared plus 6 times 0 minus 4. Well, that's 0 plus 0 minus 4, which is negative 4. So when you're at 0, you're going to be at negative 4. Let's put in negative 2 for x and see what happens there. So I'm going to have 3 times negative 2 squared plus 6 times negative 2 minus 4. So negative 2 squared is positive 4 minus 12, because 6 times negative 2 is 12. 3 times 4 is 12. So 12 minus 12 minus 4. Well, 12 minus 12 cancels, doesn't it? So I get negative 4 for an answer. Notice how it's symmetric around my 2 points here. Now let's put in positive 1, and we'll do the same thing. Let's see what happens when I use positive 1. So I'm going to say 3 times 1 squared plus 6 times 1 minus 4. Well, 3 times 1, because 1 squared is 1. 6 times 1 is 6 minus 4. So I get 3 plus 6 minus 4. Well, that's going to be 5. And then let's do negative 3. Change pen colors here again so we can see the difference. So I'm going to go 3 times negative 3 squared plus 6 times negative 3 minus 4. So negative 3 squared is positive 9. 6 times 3 is negative 18 minus 4. 3 times 9 is 27 minus 18 minus 4. 27 minus 18 is 9. 9 minus 4 is 5. So it is symmetric. Now let's graph those points, knowing it's going to be a parabola. So I'm going to start here. I'm going to make my table, or my graph. And I'm going to start with my vertex, which we said was at -1 and -7. So I'll go to the left 1 and down 7. 1, whoops, got to be able to see those points. So 1, 2, 3, 4, 5, 6, and 7. If I go to the left 1, I'm down 7. Let me change colors for that. I want to be able to see the point. So if I go to the left 1, I'm down 7. Then 0, I'm at -4, so I'll go down 1, 2, 3, 4. And notice also, when you're at -2, you're also at -4. So I'll go to the left 2. It's symmetric there. And then I'll do 1 and +5. So there's 1, 1, 2, 3, 4, 5. And then I'm also going to have -3 and 5. Oops. -3 and 5. Now I draw my parabola through that. Now here's what I want you to notice. I made the table. And here's what's going on. When I have this 3 in front of my square term, that means we're going to be adding 3 each time, but it's not linear. So what's going on here? Well, if I go 1 to the right, I'm going to be adding 3. Notice -7 plus 3 is 4, and -7 minus 3 is -4. Then if I go 2 to the right, I'm going to do 3 times 2 squared. So if I go 3 times 2 squared, that is 3 times 4, which is 12. So -7 plus 12 is 5. So you don't have to make the table all the time. You can look for the pattern there also. So now we've done, let's see if we've answered the question. I've made the table. Now let's state the domain. My domain are my x's. I can put any number in the world for x, and I'll find a corresponding point on the y, won't I? So my domain is going to be, for x, that's going to be all real numbers. Because no matter what number I put in for x, there's a corresponding point someplace on the graph. Now my range is different though. Notice my graph starts at -7 and goes up from there. I can never get a number smaller than -7. So I'm going to say for my range, I'm going to say y is greater than or equal to -7. Now I can find any other number bigger than -7 on my graph. And so that's what's going to happen. Your domain is always going to be all real numbers. That's always going to be true. Your range starts at the vertex. It's the y-coordinate of the vertex. If it's a happy parabola, because looks like it's kind of smiling at us, then it's going to be greater than that number. If it's a sad parabola, then it'll be less than that number. It's a happy parabola if your a term is positive. If your a term is negative, it's a sad parabola. A lot of work just for that little bit of little bit of a graph there.